Hi there, welcome back here. In this lecture, we have implemented lookup table for funders, which is basically our initial implementation where we are keeping the mapping of uints to addresses. And thanks to this, we can get all of funders and also funder at index. In this lecture, we'll continue. This lecture will be AI lecture, so additional information lecture, and I would like to go deeper into the storages, so I will show you how your values are actually stored on the base level in the storage. Okay, so let's start. First, let's take a look at the image I already we explained before. So there is a basically storage is a chunks over 32 bytes. It's divided into the specific slots, and the number of slots can be 2 and the power 256 minus 1. Let's take a look how we'll be storing actual mappings here, because it works differently than with the static values. All right. So back here, and I will create here a new contract, some example contract that will be keeping our mappings, or should we reuse this one? Yeah, we can also reuse our storage we already have here. We don't need to create actual contract. Okay, so let's create here mapping. Okay, and in this mapping, I will be storing mappings. Let's say we'll start simple, we'll be storing uints to uints. Okay, so let's store here uint to uint, which is a basically uint 256, but we don't need to write it. Let's provide here some names, so just some, really doesn't matter, AA, let's say. All right, and let's write it will be also public. Okay, let's create a second mapping. All right, and this will be, let's say it will be address to uint, this will be BB. Okay, so in this first one, I'll mark here, this will be, now all the slots will be moved because mapping is taking its own slot. So we are starting here, this will be slot 0 now. This will be slot 1. Okay, so every mapping is taking its own slot 1. Therefore, this here will be slot 2 now, and here slot 3, slot 4, slot 5. What I will do here, I will also initialize here some values. We did it before, but we can also use your constructor. And the constructor is called as you are deploying your contract. Okay, so the part of the code, the part of the init code, so that's the first part of the byte code, contains also constructor, and this is executed on the deploying phase. Okay, so this is init code, a part of the bytes. So in a constructor, I can access my storage AA and BB, and I can assign there some values. So let's say AA, let's say the key will be 2. I will store here 4. Okay, let's see AA, and I will store here at the 3. I will store here 10. Okay, then I will access B, and here I need address, so I will go to Ganache, and let's copy here some address. So let's say accounts. I will copy the first account. All right, I will get it here. I will store the number 100, let's say. Okay, now we need to recompile, and we'll try to retrieve these values. Okay, so let's save it. Let's go back to terminal. Let's recompile here. So truffle migrate -- reset, and this will work differently as before. Okay, so we will try to access the first storage, and we will see what we will get. Okay, the recompiling, clear it out. Let's write here truffle console. If you remember how we can get a storage, we need to access web3.eth.getStorage at, where you need to provide a slot and the first address and then slot. So address of our contract. Okay, contract. So we are looking for a storage. Click on the storage. Let's provide the address of the storage. Okay, let's paste it here. And now slot number, right? So let's say slot 0, right? So that should be our first mapping. But you can see here, I'm keeping here zeros. So actually in my storage on the slot number, I don't have anything. And the same with the slot 1. When I access slot 2, I already have these values because that's my slot 2 are my static values. This here. But the slot 0 and slot 1 is unassigned. With the mappings, it works differently. Okay, so how can I access the slot? Slot is a little bit different because it's formatted into hash, and the hash format is following. It's a KESAC 256. All right, where you need to hash together your key and the slot. So key and the slot. Basically, I could write here key plus slot, or usually it's marked like this. KESAC together. You need to hash together key and the slot. So key of the mapping and the slot of the mapping. So our keys here, when we want to get, for example, number 4, a key here is a 2, all right? And the slot is number 0. When I want to get this here, I need to access the key of 3 and the slot 0. When I want to access address here, the value, our key is here, this address, and the slot is 1. So how can we transform it? Okay, so first, let me write here, somewhere down here, a sequence of bytes of the 32 bytes. So let's write here 1, 2, 3, 4, 5, 6, 7, 8. I have here 8. I have here 8 characters. So this should be in total, when I copy it one more time, 16. This is 8 bytes. So I need 32. I have a 32? No, I have 24. Now I have 32. And I need to, in total, 64 characters. Okay, so that's the 32 bytes. Okay, I have here 0x and the 64 characters. This means 32 bytes. Okay, this will represent my key. So my key is 2. And in a hexadecimal, key is 2. Okay, so in hexadecimal, it will be 61 zeros and 2 in the end. And this will represent number 2. That's my key. Now the slot. Slot is a 0 here. So this is the second part, will be just a 0. So I will copy this 64 characters. I will paste it next to it. And I will remove 2. And I will replace it with a 0. Okay, so now in a total, I have 128 characters. This means 64 bytes. First 32 bytes keeping the key of the mapping, which is a 2. Here is the key. And a second 32 bytes keeping the value of the slot, which is a 0. So just a 0, 32 zeros. Now I will get the entire value. You don't need to copy the 0x, but just raw bytes, raw hexadecimal characters. All right, let's copy them. 128 characters. Let's copy. Let's go to browser. And let's go to Quetzaq 256. Okay, and let's paste it here. And one more thing here. Don't choose here text. That's very important. We are providing here hexadecimal characters. So let's choose here hex. This will be completely different value. This one here. And that's the location of your item in the storage. Okay, so let's copy it. Now let's go to terminal. And let's use here web3 eth get storage at. That's our storage address. And now let's write here 0x and I paste here this value. Okay, and that should be value 4. Okay, that's what we are keeping here. That's the value 4. Our key 2 in the bytes and 0 slot. Let's press enter and you should see here that's number 4 definitely. Okay, let's try to access now number 3. So number 3 will be just here I need to provide a 3. Okay, and here I can just need to copy it again. All right, I will decode it, copy this. Now I will access the second one. So here I'll provide this key. Oops, 0x, I'm missing there 0x. So 0x and press the value, and here is your value 10. 0a is the value 10, a is 10. Okay, so now we got this. Now let's try to get here this here address and the value 100. So I'll get the address. Okay, let's copy it. All right, and here is the number 3. So now we need to count how many bytes. See, this is 40 characters. These are 40 characters, so I need to count here from here. 40 characters. So I have selected 40 now. I will paste it here. And I will count in a total. I should have here 32, so 64. In total, 128. And don't forget, the second part is a slot number, but for my second mapping is in the slot 1. Okay, so I need to provide here 1 in the end, like this. Verify the number of hexadecimal characters, should be 128. Let's copy them. Let's go here, let's paste it. Let's get your hexadecimal representation of the hashed string. Let's get back to terminal. Let's get here get storage at. Provide here 0x, don't forget, for a hexadecimal, and paste your value. And that's the value of 100. 0x64 in hexadecimal is a 100 decimal value. So everything is correct, and that's how you can access your slots. It's done this way because if it's not static value, you don't know the size of the mapping beforehand, because in the one mapping you can keep 2 to the power 256 minus 1 values, right? So therefore, the one slot wouldn't be enough to keep all of the values for the entire mapping. So that's why this kind of the encoding is done. So you need to get a hash of the key in the mapping and the slot number, and this will get you position of the storage, position of this item in the storage. Okay, and everything is in the range of 2 to the power of 256 minus 1, because also KSAC 256 will get you 256 bits. So also this number is in this range of 2 to the power 256 minus 1. All right, guys, so that's a little bit in the details of the mappings. Now you know how to you can access them in the storage, and now you know why everything is public on the blockchain. Because if you know how to count it, you can access basically anything on the blockchain. All right, guys, this is gonna be it from this lecture. In the next lecture, I'll show you how you can extract values in the storage of the dynamic arrays. So for this, I hope to see you in the next one. Cheers.